guys, welcome, and girls. So I'd like to welcome everybody on behalf of Hacker Dojo and the Laptop Music Production Workshop. Anybody here? You want the music down a little?
Thank you.
Okay, so you can hear me now? So we wanted to bring you a special guest speaker tonight. For anybody who doesn't know the Laptop Music Production Workshop, we hold a meetup here every 2 weeks, and we're focused on listening to each other's tracks and giving each other feedback for different types of music, different types of genre, but we're particularly interested in a lot of the things that we make inside the box and how to do that better. Andrew Belt, who is with us today, is from VCV Rack. This is an open source virtual synthesizer, a modular synthesizer platform that he has developed. And it's a very exciting platform because he's got over 100,000 users and contributors working on it. He basically left his PhD to develop this product. And when others in the market could have brought it, they were going too slow for him, and he decided, I'll just get the job done myself. And so today, Andrew, who has traveled across the country from the south, is here with us, and he's going to talk a little bit about his synthesizer, and afterwards we will definitely open this up to questions. Also, if you have any questions about either Hacker Dojo, or you have questions about the Laptop Music Production Workshop, we will also be happy to talk with you after the event. So our plan is just to let Andrew talk for a bit, and we'll see how long we go, and if we need to take a short break, we will, and then we'll have a Q&A session at the end. Without further ado, Andrew Belt.
Cool. Well, thanks for that wonderful introduction. That was like the first half of my talk, so I can skip ahead for this. First off, I'm Andrew Belt. I'm from Eastern Tennessee, right under the Appalachian Mountains. And I traveled out here as a sort of vacation. I was talking to maybe 4 people on Facebook who I'd known who were in this area. And then I realized that there were probably 100 people that wanted to meet me, not just them. So I said, why not do a talk and just mass produce the meeting? So if you want to come up to me and just ask questions later, or if you want to ask questions during the talk, absolutely just raise your hand and I'll pause at any moment. So first off, who in this room is familiar with VCV or VCV Rack and its plugins? Okay, that's the large majority. I'll still give a good introduction about it, but who here is familiar with modular synthesizers or Eurorack, which is the things that VCV is emulating? Okay, about the same, I think. And then who has a modular synth? Okay, I'm going to raise my hand for that one.
VCV Rack.
Yeah, why would you need it? So I have what I call my business Eurorack because I have to keep these modules around for testing purposes, but I've kind of switched over to software as well for my own music production. I'm also kind of a jazz pianist, so I'm less of a modular performer than most people imagine. I'm really horrible at this. I didn't make this at all. It sounds really great. If you walked in earlier, you heard the first part of this. But there are several people that are just amazing at making sound come out of this thing. And I understand the details, but not how to really get things coming out of it. So that's fantastic that people know kind of the general environment. But VCV is an emulator for the Eurorack system. The Eurorack system, I think, was launched around 1995 by Dieter Doepfer. And he was attempting to bring a cheaper platform onto which people can build hardware. And his ideas were kind of based in the Bob Moog and Don Buchla synthesizers. Buchla is from Berkeley. He launched some synthesizers around like 1967 or so, and then Bob Moog around the same time. So this stuff goes really back into history, and this is kind of what the first synthesizers were. Instead of having a single keyboard attached to a soundboard that could play multiple notes, you just had a bunch of sound generators like filters and oscillators, and you would turn the knobs to give you, adjustment of a certain parameter, and then you would patch one module to the next to kind of design your own control chain or signal chain. And from that platform, people were able to develop the synthesizers that we listen to today in most pop music or electronic music. But there's been a rejuvenation of the modular concept because people want to kind of go back to the beginning and mess with synthesizers in ways that people haven't really touched in the last 40 years. So VCV is a platform that lets you do that without buying a $20,000 modular synth. I think the price has decreased a little bit, but it's still, around the price of a car. And a lot of people don't have that, time and money to invest in the hardware. So that's why I developed VCV. About 6 years ago, I released, I didn't actually release, but I developed a C++ API where people can write in a command line interface and connect modules together. But it was sound only, there was no UI, it was all terminal based. It enabled people to type in a command like add module, and then you select the module, and then connect port 12 into module 3, port 5 or whatever. And that's how you patched. And then about 3 years ago, I started developing a UI for that, rewrote the DSP engine, and this is kind of the result. So this is VCV Rack. I have completely forgotten who wrote this batch, but this is an example of what you can do with it. It's a non-linear way to edit and create electronic music. And so I think by the end of this talk, you'll kind of imagine how many possibilities you can make out of this. Let's see. So this is the general UI of VCV. For the people that have used it before, you would be familiar with this. You can take a cable, like one of these, you can unplug it and then patch into something else. You can create a new cable by just dragging, and you can never even see that, like from the back, because I can zoom in. And then you can change the mouse by just moving your mouse up and down over it. There we go. So when you first download Rack, now you'll get a default patch. Let me see if I can reset this. All right. So this is kind of the base patch. You can start with nothing, and you just get these Rack rails, and it's just a template for you to begin your patch. But we've included a default patch, which is a little subtractive thing. And let me connect the audio output. Okay. So what I have here is I have a MIDI interface, which is converting MIDI notes into CV, which is control voltage. And that control voltage is literally in the units of voltage, and I can change the voltage from like 0 to 10 volts or so to give different modulation, pitch, effects, and all that stuff into this platform. So right here, this gate input is going to light up because it's going from 0 volts to 10 volts whenever I press this button. And that gate will pass through a VCA right here and a VCF to open up the sound so you can hear it. The V per oct input or output would give you your pitch, and then this is how most synthesizers are sort of designed if you go out and buy a little mono synth. So you can get all that sound from here. Modular synths can do a lot of things, but they can do subtractive patches all day. So I just kind of started out with this as the default, and you can build on top of this. What you can do is right-click on an empty rack space, and it's an infinite space. It goes all 4 ways. You just have a little palette here. You can right-click, and then you can search for a module like LFO, and then I can take this port, like a sine output, and then let's go into the FM. So as I move this knob up, I can modulate it with this new module that I just added. So you can do anything that your mind inspires you to do. That could be kind of the basis for a vibrato, actually. Yeah, so if you want to understand how synthesizer patches are made, this is a really great way to do it by just doing it yourself and implementing all these ideas yourself. So as she mentioned, there's about 100,000 users, and it's been out for, I think, less than 2 years. Its 2-year birthday is September of this year. Since its launch, it has 150 plugin developers using this open API or open SDK that the software gives you. So if you know C++, you can just program into this software and create your own modules. You can ask a graphic designer or design a panel yourself, and that's how most of this stuff comes to be. I think of those 150 plugin developers, they've released about 1,200 modules now. That number is always increasing. There's at least one module being released per day on average. So you can really dive deep into just a single module and then integrate them together by building a patch. A lot of the modules are designed to be really intuitive. Some of them are designed to not be intuitive. Since I'm wearing this t-shirt, we have these Geodesics modules, and this is kind of what the logo on the t-shirt is. This is designed by two Frenchmen, I think it's Marc and Pierre. They've used this open API to write their own digital signal processing code and then write their own graphics into this software. The graphics are all SVG, so if you can use Inkscape or Illustrator, then you can make your own panels and knobs. And then if you know C++, you can then integrate all that stuff into one plugin, which is what you see here. This, I think, is some sort of sequencer. It spins around, and then all these knobs can kind of control what the pitch is, depending on the state of the module. And I could just talk about this, every single module for an hour at a time. It would take me 1,200 hours to talk about. But it's a very unlimited platform, and if you are really interested, you can go download it at vcvrack.com. It is open source. The platform is fully open source and free software. But the way we fund this project, or to fund VCV, is to sell commercial plugins. So I think of those 1,200 modules, about 200 of them are commercial, which also means that there are 1,000 open source ones, so you can't, you're not going to hit a limit just by using the free ones. But if you want to kind of expand your sound palette, you can buy the commercial ones. So right now is kind of an important moment for VCV and all the VCV developers. Version 1 has just released, which means that it is now a stable platform, which you can play shows with. You can record audio and release a whole song that comes out of just this software. A lot of people put together a 10-minute composition and then release the WAV file recording and maybe release the patch file so other people can download it and start playing with the rack as they recorded it. So I think it was like June 19th, so it's this version is not quite a month old, but everyone has kind of ported over their plugins. There's a little bit of a growing pain, but I think that's mostly in the past. There's always some teething issues that 1.0 software always experiences, but of those 150 developers, maybe 145 of them are still around and working hard to get their plugins up to date and everything. It's a really strong community. Since a lot of this stuff is open source, many plugins are kind of derived from other plugins. So you can take the source of any of the modules you see here, and you can edit them and release them as your own, maybe with a different panel or more knobs or ports or better DSP or something like that, and you can use that to kind of base your own plugin to make your own creative design if you're a programmer or a graphic designer. So since I have this default patch here, I'm going to show off my favorite feature. So in the late 60s and early 70s, all synthesizers were monophonic, so you could only play one note at the same time. And now we can just duplicate all of the back-end engines of all these modules and then put in multiple voices. So if I right-click on this MIDI CV module, which is converting, I can put this more up, which is converting the key commands, or if you had a MIDI keyboard or some sort of controller hooked up, it would convert that into the language of the 70s, which is CV and audio cables. And when it converts all these MIDI notes into CV, it's going to duplicate the cables on the output. So I can spawn out 4 voices, and then if you noticed here, the cables just got a little bit thicker, and that represents that they're storing 4 channels along one single cable instead of just one. So previously they were monophonic cables, and these are the polyphonic ones, which happen to be 4 channels because that's what I selected here. And what really happened behind the scenes is when I right-clicked and selected polyphony channels in here, it generated 8 channels on all of its outputs. This VCO, which is always running, it's producing audio right now, even though you can't hear it, because that's what modular synthesizers do. It's now just continuously generating 4 different channels of audio based on the 4 pitches that are being fed into it. And so when it generates 4 outputs, it creates a cable which is also a fat cable. It's going through this filter. It notices that it has 4 filter input channels, and then it'll generate 4 output channels. And so this chain of polyphony propagates to the entire system, and then I can play 4 notes at the same time. So there's a lot of magic that happens behind the scenes, but every module developer can implement a polyphonic module by simply reading in the number of channels of a cable instead of just assuming that it's 1 and then producing in or 4 or 16 different output channels. You can also change. So that's a really good application of polyphonic cables is polyphony, but you can also use it for other things like ambisonics. If you have several channels of output audio, you can just compress that down to 1 multi-channel cable and use it that way. So it's not just for polyphonic applications, they're just generic multi-channel cables. And then at the very output, the Audio 8 module converts the virtual world into the real world, so that's why you can hear it. But if I send a polyphonic cable into an audio module, it's going to sum all the channels together because I can't play 8 channels of audio out of here. I can only play 1, which I think is just the left channel actually. So through here I have 4 channels. They're being summed, and then that's what you hear. It's just a superposition of each of those channels. Polyphony is one of my favorite features because I'm a pianist and I like giving it 16 voices at the same time while patching just 1 monophonic patch to start off with. Another one of my favorites is I have a lot of MIDI-enabled hardware, and so I can spawn up a MIDI output module. So I can take the CV to MIDI. I don't have a device here, but what I can do is just send this new module, an oscillating pitch, and if I plugged in an external synthesizer, then I can generate notes that are going up and down like this LFO is. This kind of enables you to use your existing hardware or other software on your computer with VCV as long as it supports MIDI. And so I have like a Juno 106 synthesizer, which is one of the first fully MIDI-enabled synth, and I can just plug in my audio interface or my MIDI interface into a computer and have the keyboard generate the sound from the sequences coming from VCV Rack. That's one of my favorite features. And then, of course, I could look in the changelog and rattle off about 100 new features in 1.0. But 1.0 is this exciting platform where I think it's professional enough to be used in professional context. So a lot of artists and musicians are using this in their daily workflow. Just some standard stuff. This is really hard to see because I can't scale the GUI up. But as I mouse over these knobs, I can see the value, and this one says, let's see, this one says 2 hertz, so it's oscillating at 2 hertz. If I right-click and select like 20 hertz, I can just type in 20 hertz, and it'll start oscillating at 20 hertz. So all this stuff is new from the old 0.6 version, and this is kind of the main line now after being used. Oh yeah, a few features. You probably saw me zoom in and out. This is a really fantastic, kind of underrated feature in my opinion. It's sort of like Google Maps. You can see the bird's eye view, and you can have like 500 modules if your computer can support it, and you can just keep adding things until your computer dies. And then if I zoom in, I can get really intimate with like the scope if I want to see what's going on. This is also a polyphonic scope, so in addition to playing one channel, I can see multiple channels with just multiple traces of the scope. The scope is a really great way to kind of visualize what these signals are, because a lot of these modules are not as simple as just an oscillator, which is producing a sine wave, or a filter, which is filtering a signal. A lot of them do really weird things, and it takes me an hour to figure out what it's doing, but the scope is a really good way to sort of interrogate that synthesizer, or the module that you're working with. The one rule about VCV Rack is that everything is just a voltage. It could be audio, it could be CV. It doesn't have any idea what those are, it just knows that it's a voltage moving over time. So I can plug in a VCO into the pitch input of a VCO to make it what's called an FM synthesizer. They really like that at Stanford because it was invented by a Stanford professor. And then Yamaha licensed it and released the DX7 and things like that. But now you can create all those patches by just stringing together multiple VCOs. I can just duplicate it right here. I can have 4 different oscillators, plug a sine wave into the FM of 1, and then now, let's see, this will. So this is just normal FM synthesis. That's just a normal sine wave, but you can do wave shaping. Anyway, there it is. I could stack up as many as I wanted and start, programming these FM patches. Another rule of VCV is that every cable induces just a 1 sample delay. So if you're familiar with other systems like Ableton Live synthesis, or let's see, Ableton Live's like VST plugins or Cubase's VST plugins, you process a buffer of audio. So every like 128 samples, each sample is 1 over 44.1K seconds. It'll produce a block, and then each block will be sent to the next VST down the line. With this, it's a little bit different. So you kind of have to rethink how things work. Everything has just 1 sample delay, so when I play a note with this MIDI CD, it takes 1 sample, or 1 over 44.1K seconds, in order for that signal to get to a VCO. And then the VCO, that sample later, will send it to the VCF and so on. But what this does is enables you to create feedback patches where a VCO is maybe modulating itself, or it's modulating another sine, which is then modulating the first sine. So you can do all these things that you can do with the original Moog and Buchla and the Surge synthesizers from the 70s. That was a big design goal, is to make this close as possible. And among those 1,200 modules, you have probably 500 sound generating ones, and a lot of them are based in these old concepts. And then sometimes people come up with brand new concepts, like mutable instruments, for example. So we'll pull that up. If you're familiar with the Eurorack synthesizers, there are probably 300 companies that are releasing Eurorack hardware. And VCV has many of those available for this platform. So instead of buying $300 worth of a module, you can try it in here first. And if you don't like it, you don't have to buy it. If you like it, then you can go and buy the $300 module, or you can just continue using it in the rack. So the first, let's see if I have it here. The first plugin that we released was the Audible Instruments, which is the virtual version of mutable instruments. And it includes all these fancy synthesizers like Elements here. And they don't really follow the classic 70s synthesis style, because this is, it's 2019, we can put processors in our hardware. And what's nice about having a digital module with a firmware is that I can take that firmware out and plug it into VCV Rack. And since it has a C++ API, any language which is compatible with that can be compiled into a plugin. So let's see. So this simulates like it's sort of it's a modal synthesizer. So it'll simulate the modes of a piece of metal or a string or something. You can modulate pretty much everything in this model of where it goes. So anyway, if you can come up with inspiration to by using this or something, then you might be inspired to add a bunch of other sounds, which would eventually give you kind of a full song. And some people just mess around with the modules, which is fun in itself, and then some people will actually make full creations that are 3 to 10 minutes long. Just by modulating everything slowly, and maybe have some arrangement modules which allow you to kind of have different sections of a song. It's very different from the Ableton Live Cubase sort of pattern, where you have tracks and clips and you just play those clips. Everything is fully modulatable in this platform, which lets you, it might be harder when you start out, but eventually you kind of get used to the fact that you can plug everything into everything and control every single knob at the same time. Anyway, so I showed off, you can right-click a knob and change its value just by typing it in. So if I want to make the attack, like 1 second, or let's say 500 milliseconds, just type it in. And that's something you can't really do with hardware. You have to dial it in and listen to it. Some people don't like the ability to dial things in very closely, so you can actually disable that feature. And so I don't see it here. It's really hard to even convince them that they can go in and do it. Yeah, you can just disable that or whatever. Also, yeah, so to move a module, you just click and drag it. It's kind of difficult because if you're making a patch with like 300 modules, you might want to move clusters around. So if I want to put a module in between here, I right click and, oh wait, it doesn't fit, so I have to move this module back and then put this back and move this. But now what you can do is have this feature called force dragging. Click a module, drag it, and then hold in Command or Control on Windows and Linux. And then you can just drag everything at once. So I can put a module in between here and just squish it in. It's a really great way to kind of organize things. You absolutely can't do that with hardware. I guess if you unscrewed everything, then you can just shove everything to the left. But
because you have the arm and back, so you can.
Yes, yeah, that's right. You have, you would hit the power headers.
Just stretches.
Yeah, everything about your rack is relatively expensive. I mean, like the rack itself might be $1,000 for just something the size of what you see here. And so once you're $1,000 into your hobby, you still have modules to play with, and then you've got power to worry about, and you've got to buy your cables. So this just kind of makes you forget about all that and then play with modules the way that I think Don Buchla and and Bob Moog intended is just to let your creativity flow. Although computers didn't exist back then, so now in 2019, we can do this. So I've been kind of showing off the Modular Browser. I have 946 modules installed out of the 1,200 ones. These black ones are from a company or individual who brands his modules as Volt. And here's one of his blank panels. It doesn't do anything, but some people like just keeping this stuff in their rack just to but yeah, it's just amazing. You can have this module and let me stuff it in the middle of here. This is a drum synthesizer, and so if you like programming your own drums, you can modulate anything you want here, and here's your inputs, and there's an output. A gate is how you would trigger this to hit the kick drum or snare drum or however you've programmed this. That's just one module. I've spent all day trying to learn how a single module works, so it gets kind of overwhelming, to be honest. Let's see, we've got here's the wave head. I love this blank. For the rest of the talk, I'm just going to show off the blanks because they get really interesting. I think Volt has a blank. Let's see. No, it's Geodesics. Let's see. So in this blank, I think there's a secret. Yeah, here we go. It's actually a port. I'm totally wasting time here. Showing off the good secrets. I should keep this a secret. Oh, maybe there's another. Let's see. Well, it's generating something. I think yeah, here we go. This is a knob. I'm just trying to see clock frequency. There might be another one hanging around here. So I don't know. Pay attention to your blinks. They might actually do something.
What's that deleting thing?
Oh yeah. So it operates like a first-person shooter. You just hold in the delete key and then you can just swipe. So you can delete a lot faster than you can add, but there's also undo. I can recreate.
Yeah, undo is much appreciated.
Yeah. No, it's kind of a weird interface. A lot of people need like rectangle selection and stuff like that, but with this force moving, you don't really need it. It's a little bit more physical, like you're moving around boxes or whatever. It's a creative platform, so if you start using this like a CAD program, I think it kind of kills the mood. So I really want to just make this as smooth and buttery as possible. Just a design decision, I guess. Okay, well, that's most of Rack 1.0. I think I promised in one of the Twitter posts that I'd show off some upcoming modules. So it seems like over half of you use VCV Rack. If you want to play with more Eurorack hardware in the future, we're starting to work with a lot of other companies to do that. So let's see if I can. Let's see. I launched this from the terminal. I've got like the development build up here. So this is a new module from Grayscale called Permutation, and it's based a little bit on the Turing machine by Music Theme Modular, Tom Whitwell. These are currently disabled. The DSP doesn't do anything. I just paneled them up and then disabled it since it's not complete, but these will probably be released within a month. But I'd like to show this off because this is another Rack 1.0 feature which I think is pretty valuable. Not a lot of people have seen this because there are only like 10 modules that take advantage of it right now. But suppose you want to extend a module, say the permutation is pretty huge. There are smaller versions that you can just spun up. But if you want to have more outputs or more control, you can add this variant module. And it communicates with the permutation modules by just simply putting it to the right. And so now these two modules are bound together and they become sort of the same module. And if I disconnect them, then it turns off. So the brain of variant is actually permutation. So I can take a mixer concept and it might have 8 channels. But if you want 16, I can maybe design a module that is its own expander. So I can just double the size of my mixer by just putting 2 of them right next to each other. And then they'll all be mixed into the same output bus. This is not new to hardware. In fact, these are hardware modules. They communicate using a bus cable in the back. So I would unscrew these modules, plug them with a cable that comes with the variant purchase, and then they'll become one brain. But you can now do that in VCV. So I'm excited about permutation. I use the algorithm module a lot, which is this one. But grayscale sequencers are just really fantastic. And this is also a free plugin. It's not open source because it is a hardware manufacturer, but you get all the stuff that comes with it. I can drag this variant and just put it here using that force dragging feature. And now this permutation here controls the variant. So you can patch it up and then switch out what module I guess you could say mother module is. I think once I start sort of advertising this feature, more modules will begin using it, and it'll become easier to patch 2 very similar modules together instead of having to drag cables back and forth. Now, of course, dragging cables is the appeal of the software, so that'll never go away, but you can do it if you wish. You can just find 2 modules that expand on one another and use that. Another manufacturer, which is very exciting to announce. It'll include about 14 modules, which are, I think, most of the modules they have in hardware production right now. But we have these new molecular modules. So if you've seen the voltage block and the variegate, or the variegate 8, we now have these available, or we will have these available very soon. It'll be a commercial package using the same firmware that came off of the Moleco digital modules. And then we'll have, I think, 11 more, so you can buy these as a package. And the more that VCV works with hardware companies, the more you can build an actual hardware emulation that you can actually go out and buy if you feel like playing live with hardware. So it's a good opportunity to experiment with real stuff that you could actually purchase. It's sort of like the Modular Grid website, which shows off all the modules that are commercially available in hardware. But now you can actually just load up these modules and start playing with them. So if you've ever wanted to, some people, if you're familiar with Eurorack, might make a modular grid patch or rack, and it'll display JPEG images of each module side by side, but you can't actually play with it. But this software will allow you to do that. It'll be a full emulation using often the same firmware. If it's an analog module that is emulating, then it'll use virtual analog models to simulate this stuff. And many of them will be free, many of them will be commercial, some of them will be open source even, and you can just play with this like you're using a real Eurorack. And then if you decide to buy a Eurorack in the future, you'll already be an expert, and you'll know exactly what you want, what to get, and so on. And then the last announcement for new modules that are coming out are these 2 new Bifaco modules. Anyone that's used VCV have probably seen the Bifaco modules before. They're these very creative designs which aren't really based on existing ideas. This is called a burst, and it takes 1 pulse and then sends out just a burst of random gate signals or triggers from it. And so if you want to simulate like a bouncing ball that accelerates in speed, you can use burst to do that. Or if you want to kind of, if you have a single clap sound, if you overlay a lot of claps very fast, it becomes sort of like an audience clapping. So it gives you more depth of your drum sounds if you want. So this is a really handy module, and then a Mux Slicer is just a really advanced sequential switch. We have a smaller, let's see, sequential. We got a smaller sequential switch here, but this is kind of an expander with it with attenuators here. We also have one commercial one. I should probably be showing this off more, but if you let's see. Oh, this is the dev version. Let me switch over. So yeah, this is a commercial module. This is one example of how you can purchase modules to get really big, well-designed modules. This supports the VCV development. So if you buy Pulse Matrix, which I think is $30, maybe it's 20, I'll have to check, but it's between $20 and $30. That money will go directly to me and my graphic designer in Seattle, who will create more modules and develop the open source side of the VCV Rack environment. I don't know of too many business models which release this much open source stuff, but the idea is as long as people are buying the commercial modules to kind of expand what they can do, that money goes directly into supporting the base software, which they get to use, and it enhances their own setup. But it also enhances the setup of, or the workflow of 100,000 other users. So it's a really great way to fund a growing, very quickly expanding platform. I think some people would call this like an open core model. But I think it's more than that. It's more like just a big ball with some other things attached to it. Almost everything is open that we do, except for these commercial plugins. That's the business model of VCV. It's pretty simple. We also have, let's see, a large console. So if you want to use VCV Rack like a DAW, like Cubase or FL Studio or something, you can, add all these modules that kind of turn it into that familiar UI. We'll be announcing soon or offering screenshots soon for 3 new DAW-like modules. We'll have an automation source, and in Ableton Live you can easily draw an automation curve and then replay that in a clip editor to kind of manually modulate a certain parameter like a cutoff filter. We'll have those available for this as well, so you can take your, you can just draw with your mouse or move curve editing tools, and then you can trigger it. It'll start playing, and then you would route that to a cutoff filter of a filter in a subtractive patch or something, or in a generative patch, to kind of add your own human feel into these otherwise analog modeling or digital modular modules. Let's see, one more. I really like Parametra because a lot of DAWs have that like 8-band EQ style, so you can do that here. And you can EQ your master bus, or you can play this like an instrument. If I modulate it with an LFO, I can just plug this into the filter cutoff here. And then if I enable this, then I start getting all these weird movements which are modulated by cables. So this is how it's taking the DAW concept from other companies or other software packages, and then putting it in a module or in a virtual module context, so that you can treat it like a synthesizer from the 70s, but get these modern concepts out of the DAW. 2 new modules, or 2 other modules that I don't have released yet are a timeline editor, which will be this enormous module. It'll take up about this much space. I think it'll record 6, maybe 5 channels, and so it'll have 5 inputs on the left, and then 5 outputs on the right, and then a big clip editor in the middle, so you can record on a track run an oscillator or your voice through it or whatever, it'll record a wave file, and then you can play that back whenever you trigger it. And then you can kind of record your own song and then mix it and replay certain tracks. You can rearrange things. You can add 2 of those modules, drag audio clips between them. So you can basically expand your timeline as much as you want in this sort of virtual world. So I do a lot of recording and production, which is based on that timeline or clip editor pattern. And being able to use that and modulate certain parameters like the speed of playback with an LFO would just be like amazing to me. So you can also have just 2 timelines running at different rates or different time signatures or whatever. The possibilities are endless, and if you want to go back to the root of synthesizers or the modular synthesizers, you can do that. But if you want to mix both, the best of both worlds, then you can do that as well. And then finally, a piano roll editor, we have that coming. So if you like dragging around the grid of MIDI notes, we'll have that. That'll also support polyphony, so you can have 16 notes playing at the same time, which will then be sent into a polyphonic cable. And then you can synthesize, however you want, just by plugging in the pitch and gate output from that module to another like sub patch or whatever. Oh yeah, one other question for you guys. How many of you are software developers and or know C++? Okay, quite a few. I gave a talk at Stanford, and a lot of people had experience in creating VST plugins, and they wanted to see how it's done here, because like I said, 150 developers have developed plugins for this, which is sort of an explosion rate, considering it's been out for less than 2 years. For the non-programmers, I think this would be fun just to see how something is created in this platform. Because I can scroll here and there are bazillion modules. These are some of my favorite third-party ones. The Bog Audio and the Volts are my favorites. The Geodesics. So all these people, Nice Sphere. This is a really cool module. It's like a sampler. I can load a wave file and then play it back at certain rates and slice it up and all that stuff. So it's got a lot of the things that you find in other VST plugins or other digital audio workstations, just in a modular environment. So you get the modular ability to control everything, but the convenience of all these samplers and things you find in a DAW. Let's see. Oh, yeah, these are really good, the horror modules. He's a one-man workhouse. It's like, he's got, I think, 140 modules with one plugin. And there aren't that many days since he's released this software, so he just pumps it out. It's amazing. Okay, so anyway, I have a terminal here. Let me make this not invisible. Let's get any bigger. Okay. So the question is, can the people in the back see this? Is that good enough? Okay. So yeah, a lot of people have been asking me how you create a module. It is C++. We'd like to support scripting languages in the future, ones that are designed for audio. So if you've used Faust or Chuck or Julia or Python or JavaScript, you can then be able to write your own DSP and sequencers and all that stuff into this platform. But for now, it's C++. So what we're going to do is use this helper script, which is newly released in V1, and it allows you to just create a C++ project which is compilable into a plugin. So let's create a plugin, and let's call it my plugin. And So it'll just ask you, it'll interrogate with all this information, which you can fill out later. And then it says I can just CD into this directory. So now I have a my plugin folder, which I created. It uses make files, so I can just type make, and then it'll compile. And then the end result is I have a plugin.dilib file, because I'm on Mac, it'll compile a Mac version. Plugin.json will include all of my metadata. So all this information that I failed to fill out is in here. And then it's got a source directory with my 2 source files. And then also a res directory, which stands for resources. And I can just throw an SVG file in here and use that as a panel. So let me see, I think I have one. Yeah, okay, so I pre-made an SVG file, and it looks like this. It's gonna be really lame, but it's a little sine oscillator, and the circles here are these sort of color-coded templates. So each of these represents a component which I can control with C++, or the user control with their mouse. So now that I have that, let me copy that SVG file to my resources directory. You can use Inkscape or Illustrator or whatever your favorite SVG graphics program is. And now I have the module panel in my resources directory. I then go back to my helper script, type in create module, and then let's make my module. And so what I'm going to do is take my resource SVG and then automatically look at the positions of all those color-coded circles in the original panel, and then create a C++ file from that. So now I'm just going to run this. It'll ask me some more questions just to make sure, like what the type of module it is. And then it'll tell me I need to edit one file. So let's see if I can do this. Okay, so I've got it. Yeah, here we go. I cannot change it. There we go. Okay, so it generated a plugin.hpp file, and then it'll tell me to add these lines. This defines the existence of your module. I then add this line here to tell Rack that my module is available. And then here's the file that I just generated. So it recognized each of those circles, and it put a pitch knob, because I named it in the Illustrator file as pitch. A pitch input, a sine output, and then a light, which I just called blink. So, so in this process function, this is the DSP kernel, which generates the next sample of audio at all the outputs. So what it's going to do is take the state of all the inputs and all the parameters, and then it'll write out to the output voltages, or the LEDs if I want to make it blink. I'm just going to leave it blink for now, so it'll do nothing, but this mess here is what the C++ generator script wrote out. And so it put screws on my module, it created a parameter called the pitch param at the location defined in the SVG file, and then it should be good to compile. There's very little you need to do after the scripts. So I can just run make again. And then once it compiles, I can then go back to Rack, and theoretically I should be able to use my new module. So let's right click here, and then here it is. Here's the my module plugin. And I haven't deleted the color-coded stuff in the file yet, but what you would do is go into Inkscape or whatever, and then just disable the layer, and then it should be good. So here's my pitch knob. I can adjust this. Here's my pitch input, which I can use to control the pitch from the voltage. And then here's my sine output. So I'm not going to implement the DSP here, but if you'd like to play around with DSP, this is a really great way to get started. Sine oscillators are kind of like the best way to get into DSP because you automatically don't have the aliasing and all the issues that come up with DSP. So if you'd like to start learning how to use modules, this is a great way to start. I just kind of leave it as an exercise to fill in the DSP for this. But I also give an example of how someone might do it. There are an infinite number of ways to implement this, but that's what gives all these varied modules in this platform. So, if you want to distribute this module, you just type make dist for distribute. It'll generate a release binary, and then in the dist folder, I now have this my plugin dash the version that I failed to type in. It just defaulted to 1, and then it generated the Mac binary. So if I want to give this to my friend with the Mac, they can use this. If you want to compile for Linux or Windows, since Rack works on all 3 desktop operating systems, you can submit it to the VCV build system, and it'll build that automatically for you. But you can use this and share it. So the files are pretty lightweight. I'm actually really curious how large that file is. 20 kilobytes is pretty good. Most computer scientists would get interest from that. So. Okay, I think that's most of what I have. That's about an hour. I don't know how much time I have, but if you'd like to ask any questions, now's a great time. Let's see if I can open a patch first. Let's see. This is also not mine. Don't know how to credit it because I don't know the original artist, but he's a pretty good patch designer. If you've heard of code golfing, it's kind of the practice of compressing your source code into the fewest number of lines as possible. You can do that with modular synthesis and just use modules that are small and powerful that can do what you want in the smallest amount of space. And so I think this is kind of what this guy did, because he's using all these bizarre modules to get this weird ambient texture. But it's pretty easy to make this if you have something in your mind. Yes.
So I have a question. One of the first things you showed was how you did polyphony for layers.
Yes.
So when you do that, that's implemented within the actual module itself. It should be coded to have 4 voices.
Yes, the module developer does have to add for loop to loop over those voices. It's not going to automatically copy the engine 4 times for you, because there's some major benefits of getting polyphony as oh, sorry. Turn it down and turn it back up. Speak closer. So what you can do is
more efficient to do it in the
right.
How do you make sure? So if you wanted to have those, like if in a regular modular synthesizer, those oscillators will be slightly out of tune with each other.
So that's one of the examples of why you actually want to process using in channels with one engine, because you might have a module that creates a random slew and separates a voice. So you can take one monophonic input, expand it out to 4, and then add pitch detuning a little bit. So you can create like a unisono effect just by using one of those modules that will split it. Oh yeah, this is an example of what I'm talking about. You can use a module called merge, and merge will take, let's give it 4 different channels. So I can take like the sine, the triangle, the saw, and the square, and then the output is going to be just one polyphonic cable that carries that signal. So there we go. So yeah, this is all 4 of those signals being merged together into one polyphonic cable. You can do the same thing with pitch and the 1 V per oct signal to allow you to to give this oscillator multiple pitches, and then the oscillator itself will then have 4 different frequencies that's generating. You can
So you could modulate the CV that's coming in.
yeah, and then at the very end you'd have this little sum module. So I can take this, plug it into the sum, and then I get the sum of each of those 4 channels. So that's what you do at the end of your oscillator. So you would basically take a monophonic MIDI note, for example, split it into 4, detune it with a detune module, send it through a VCO or oscillator, and then combine it back together, and then you can get that unison effect that you're talking about. So polyphony allows you to do a lot of things, and that's just one example of it.
So I'll make a comment first, and just to kind of set everybody's expectations, we'll probably do about maybe 10 more minutes of questions.
Okay, cool.
And then after that, what we'll do is we'll close up, and then people can talk with you directly and talk with each other. I think that should do it. Of course, if we run over a little questions, that's fine, but just so folks know what we're going to do. And also, one question I have for you is, are you guys building out tutorials to help people learn?
Yeah, we as in VCD, we're not really doing that, but there are several third-party, people that are not associated with VCD directly that are, making these fabulous tutorials. And you can have a 3-minute introduction if you look on YouTube, or you can have like this 12-hour, TV series essentially. You can find it all on YouTube.
That sounds like a weekend.
Oh yeah. I've been watching
Sure
some of those. Yes. But like I learned stuff on my own by just watching other people play with things, because I kind of developed my own system, and then I realized that it's different from everyone else's system. So you can watch a tutorial and learn the way they do it. You can download a patch. There's a website called Patch Storage where multiple people upload their patches every day, and you can download it and try to figure out what they're doing. But yeah, there are probably 10,000 YouTube videos out there about this software right now. If you purchase our plugins, we'll have tutorial videos for those as well. I hire that out though because I've got several people that are just amazing at maxing out the capabilities of the modules that I design. I'll have no idea that you can do a certain thing with our modules, but there's like an infinite number of possibilities, so you would kind of expect that to happen. Yeah.
How much space do you need?
How much space? Like disk space? I think that the binary of Rack is like 5 megabytes, so basically nothing. And out of my like 150 plugins that I have downloaded, that's probably a gigabyte or so. It's very small. The graphics are SVG, so you have no bitmaps in here. That's why I'm able to zoom. So the file, defining this knob is just a single circle, so it's probably like 10 kilobytes or something.
But the files you make,
Sorry?
the files you make are big.
Well, yeah, the wave files and stuff.
Yeah,
right.
yeah,
Yeah,
exactly.
absolutely. We also have a video editor, or a video recorder called Recorder. And you can just right-click and choose like MPEG or AVI or whatever. And what this will do is you plug in audio like this, and then you adjust the level of it to make sure it's not clipping. And then you just hit record. It'll ask you for the file. All right, let's put it here. And then now it's recording the video. So you can record your own patches or patch videos by just hitting this record button and then outputting to a video file.
What do you record? You're recording the screen here?
Yes, yeah, all of the Rack. It's not going to show off like the title bars or anything, but everything within the program is recorded, and then you can go back and watch it and publish it on YouTube or whatever. A lot of Eurorack hardware users get out their cell phones and record their patches that way. So it's the same thing. You just record your performances as is and post on YouTube. You have a question back there?
Yeah, so it looks like you're running it as a standalone program.
Yes.
But like, can you run as VST inside the DAW as well?
Not yet. In I think December or January of next year, so less than a year from now, we'll actually have a VST plugin of this. I think of this as a DAW because you can record a pop album in it if you really wanted to try doing that. But a lot of people don't think about it that way. They think of it as a single synth where they can just set it and modulate things using automation within Ableton or whatever. So we will have a VST plugin available. We will probably have an audio units for all the Logic users out there, and then maybe AAX for the Pro Tools users. And that will actually be a commercial product at around $99 next year. But the standalone software will always be free, which enables you to view the source code and try to make your own modules based on how everything works.
And you can take MIDI and audio into and out of the standalone?
Yes, here's a really great idea. So if I select instead of the built-in output, just the microphone, I get these bottom portions, and now this green LED is saying that I have input coming into the system. And so I can use my oscilloscope to record my voice. So here it's actually listening to my built-in Mac microphone, but I could plug in like a 16-channel interface and record a jazz band with it. I can modulate this audio using all these weird audio effects. I really like Valley. Yeah, Valley has this plateau reverb, so I can just take my audio input, go into here, and then let me duplicate this and add an output here. Let's see if this works. Hello. Okay, go on. I definitely heard something there. There's something going on. Hello. Check. Hello. Hello. Okay, I don't know. But yeah, in theory, you should be able to. I think I'm just not loud enough or something. I did hear something initially.
Yeah, I think you got it.
Okay, cool.
Can you say something about the latency in the system? Because you were talking about having 1 second delay between like a lot.
Sorry, one sample delay.
One sample delay. I don't quite understand how you can do that in a kind of multi-threading computer. But
Oh yeah.
but then when you go to the output, you've still got the buffer latency on your output, right?
Yes, yeah, and I can set that depending on how powerful my computer is. So I can go down to 64.
Sure, yeah.
But yeah, you're right. Within the virtual rack engine, everything has that one sample delay, but at the output, I need to wait on the audio interface to play back its buffer, and then when it's done playing back those 256 samples, then it'll ask rack for more audio, and then I supply it, and I just go back and forth like that.
Yeah, but if you could, in theory, get that signal out and you didn't have to buffer it, you could get a really, really low latency.
Yeah, you could. I think, desktop operating systems are not designed for real-time stuff.
Yeah.
So, yeah, the system is virtualizing in that one sample delay, but in reality, you can't escape the fact that you have to wait a few milliseconds to get audio out.
Yeah.
So it's not a secret, or it's not like some amazing magic about the system. It's just, it's just like other DAWs.
I kind of get it now.
Yeah, right.
Is there some way to build like encapsulated synths like with Reactor where you can have some complicated patches and modules, but then as the patch designer you kind of have a couple of special knobs or things where you want the user to be able to tune it to just have a more limited interface. Is it possible to do that kind of thing, maybe like a front and a back or like a UI to allow people to design their own synths with this?
Yeah, so I assume you're talking about something like Propeller Head's Combinator or Ableton Live's macro thing where you get, all the modules behind it are kind of invisible, and then in the front you just see like 8 knobs, and then you can load a patch. Someone actually just released a module that, using that module expander, feature that I demonstrated earlier, you can take, I think, all the adjacent modules to the right of this new module. I forgot what it's called, but I think it's from the Pack 1 plugin, which I might not have, but you would basically put it right here, and then you can save that sub patch and you can click and drag it around, and everything to the right of it is going to be saved into that and kind of bundled up. The thing is, you can still see it there, but I can save it and then load it into another patch. And I guess you would call those sub-patches. So he's basically demonstrated that a plugin can do it. I'll probably, in version 2, maybe add that to the core software. Yeah.
Did you use any framework to develop it at the beginning, like Polyclinic?
Yeah, that's a good question. I don't use Juice, but it uses probably 14 open source packages to do its graphics. It's an OpenGL renderer. I wrote some part of the SVG renderer for OpenGL, but it uses things like NanoVG, NanoSVG, a few sample rate conversion libraries, stuff like that, but it doesn't use one core framework. It's basically just manual C++. And the reason we did that is everything has these really strict requirements when you start doing things in the modular world, and being able to have full flexibility allows you to kind of escape from the assumption that things are going to be buffered and use like software renderers and things like that. The graphics for Rack are rendered on the GPU, so that's like one reason to use the GPU renderers and stuff like that. I hope that answers your question. Do I have one more question over here? Okay.
Well, I noticed that there are some audio interfaces that are coming out now that have like DC coupler to do CD in and out. Is there a way to use those with this?
Yeah, there's no AC coupling here, or it's not going to filter out CD. So if I had an Expert Sleeper ZS8, or I have a Modu Traveler, which has like 8 DC coupled outputs, I can just send an LFO at 1 hertz through this audio 8 interface. Or if I have more, there's also an audio 16. And then later we'll be able to kind of expand these by just adding 2 interfaces and stuff like that. But yeah, so I can take an LFO, plug it into my output here, and then I get the exact voltage back from calibrated interfaces. If your audio interface is not calibrated, like the Modu, there's this big scaling factor. So like the scope will tell you what voltage a certain signal is. It might not match exactly with some of these interfaces, but it depends on what they are. So you might have to tune it. I think Expert Sleepers, which is another Eurorack manufacturer, has actually released like ways to interface his modules with the VCV. So these are supported by him, the manufacturer of that hardware. So you definitely have that capability. Even without the Expert Sleeper stuff, it works by default. Yeah.
One more question? Anybody have a last question? Sean?
Can you talk about like how much resource you need in terms of CPU? Like, is it going to work on my laptop or?
It might. One thing that people complain about a lot is it requires a lot of GPU. So it needs your graphics card to render the graphics. And vector rendering is non-trivial. So it needs a decent GPU. So if you've got like an NVIDIA or AMD, you're probably fine. If you're on this laptop, which has like a crappy Intel graphics card, there's just the built-in integrated thing. You might run into trouble, especially on this laptop. It's a Retina display, so it's trying to drive like 4,000 by 3,000 pixels. You might have trouble, but it depends. There are also ways you can. Oh yeah, that's right. Look up in either the manual or just Google around how to lower the frame rate, because right now it's running at 60 frames per second.
Yeah.
But if you lower it to like 30, it'll still be definitely usable, but you'll get better performance out of that.
Okay, so is the GPU helping?
So why about turning off the display for certain modules just to improve performance?
Well, yeah, so all the modules, like this audio aid, they're not rendered when they're off the screen, if that's what you're asking. Yeah. So, I mean, there are a lot of low-hanging fruit optimizations that we've already done, but there's also a lot of difficult stuff. So if anyone's into open source software, we will have some funding probably this year, maybe after V2 comes out, to improve those open source libraries. which would directly affect VCV and other applications that use that. But yeah, GPU rendering for vector graphics displays are still kind of a new technology. It's been around for 30 years or so, but that's not how GPUs were designed. They were designed to do 3D video games like Grand Theft Auto 5. And so a lot of people think that if GTA 5 can run on their computer, then this should run just fine. But 2D and 3D have differences. I'm rendering fonts and everything. So it's a little bit surprising how much GPU it takes up, but that's why the funding exists, is to solve that problem.
Very cool.
Cool.
Yeah. So Andrew, thank you so much. This has been an amazing
Thank you for having
talk.
me, yeah.
And I invite everybody to ask questions of either Andrew. If you have questions about the meetup at Forest, the skiing, Mrs. Ishai, here and back. Yeah, you can ask any one of us. And if you have questions about Hacker Dojo, we'll certainly refer you to somebody who can help you with that. Thank you so much, everybody, for attending, and thank you, Andrew.